Okay, so today we are looking at domain and range of a function. So domain is all of the possible x values of a function, and range is all of the possible y values of a function. So we are looking at all of the x values and all of the y values, and for today we are just listing them. And we are going to list them in two different notations, two different ways to write it. So x values are across our x-axis. So we are going to read those from left to right. Range is all of our possible y values. So when we look at the range of a function, we are going to be looking at it from bottom to top. So domain is left to right, range is bottom to top. So to list out domain and range, we are able to just list the furthest left and right, the furthest bottom and top. So to find our domain, we're first going to list the leftmost x value. So we will look at our graph and find the x value that is furthest to the left, write it down. Then we will find the x value that is furthest to the right and write it down. Okay, for range, we'll do the same thing, but instead of going from left to right, we're going from bottom to top. So we'll list the bottom y value, and then we will list the top y value. So we're not really doing any math as far as adding, subtracting, multiplying, dividing things today. What we are doing is we are reading our graph and we're just looking at the furthest left to the furthest right, bottom to the top. There is going to be a pretty common occurrence that happens, which is that our graph continues forever. If a graph continues forever, it will have an arrow, either at the left, the right, the bottom, the top, or multiple of those. So if it ends with an arrow, that means it continues forever, and we will write an infinity symbol instead of a number. If it's on the left side or the bottom, we will write down negative infinity. If it is on the right side or the top, we will write down positive infinity. Okay, like I said at the beginning, so this is where we find the numbers that we're using, is left, right, bottom, top. We are going to be writing this in two different notations. So notation just means how we write it. So we're going to be writing this in two different ways. And the reason why we're writing it in two different ways is because in different settings, it makes sense to use different ones. And so I'd rather you know both of them than you only know one and you happen to know the wrong one. So inequality notation Inequalities are the less than and greater than signs. So in inequality notation, we are going to use a less than symbol when a value is excluded, meaning it's not part of our graph. I'll kind of explain what that means for our purposes today here in a second. We're going to use a less than or equal to symbol if the value is included. For interval notation, which is the other notation we're going to use, we're going to be using parentheses and brackets. So we'll use parentheses when a value is excluded. And we will use brackets, which are like the squared off parentheses, when a value is included. Okay. I know there has been a lot of words to start today. Our examples are on the back. We will come back to this, is it a function, at the very end. We'll come back and do this at the end. So it's kind of the nature of the beginning of the unit. There's a lot of vocab and stuff. So I have one more thing I want to write here. Sorry, I should have told you that before we flipped it. For the excluded values for today, the values that are going to be excluded for our purposes are our infinities. So I'm going to write an infinity sign right here. The values that are going to be included for today are numbers. The reason why numbers are included is we can be a number. You can be 5, you can be at 7, you can be at -12. Infinity is more of a concept. So since we can never quite reach infinity, it's never included. So that's why we'll always use parentheses or less than symbols with it. Okay, now you can go ahead and flip this. We'll come back to, is it a function? So we are going to be looking at graphs, and we are going to be listing our domain and our range in these two different forms. So starting out on this first one, our domain is everything from left to right. So I'm looking at the furthest left to the furthest right. The furthest to the left my graph goes is -5, and the furthest to the right my graph goes is 1. So I'm going to write that down in in inequality notation. I write it down like this: -5, because it's a number and it's included, I put less than or equal to. And then I'm going to put an X, because these are my X values. And then I put another less than or equal to. I put a 1. So -5 is less than or equal to X is less than or equal to 1. So what that means is that -5 is smaller than all of my X's, and all of my X's are smaller than 1. So all of my X's are in between this -5 and this 1. So that's what that means. To put that in interval notation, I just write those two numbers, so -5 and 1, with a comma in between them. You don't have to list your X on this one. And then because these are less than or equal to symbols, we're going to use brackets. Less than or equal to and brackets always go together. And then for our range, we're going to do the same thing, but instead of going left to right, we're going from bottom to top. So our range, our lowest value is right here. So we're looking at our lowest y value, which is -1. That is less than or equal to y, which is less than or equal to our highest y value, which is 5. Okay. And then to write that one in interval notation, same thing. We'll just use these same two numbers, so -1 to 5. And then we put brackets on them. Okay. Any questions about this first one? Okay. So let's look at our next one then. And like I said, we'll come back to this is it a function part. So the next one we've got, our domain, we are looking from left to right. So we look at our little graph and we find the furthest left thing. So the furthest left thing is right here. And so that is at 1. So my domain starts at 1. So it's going to be 1 is less than or equal to x. And then the furthest thing to the right on my graph are these arrows. And they're both going out to the right. So that means that my graph continues forever to the right. So I'm going to put is less than positive infinity, because my graph keeps going forever to the right. Okay, for interval notation, we write 1 comma infinity. For the 1, we use a bracket. For the infinity, we use a parentheses. Okay. Any questions about that one? So the big thing is that we can mix and match those brackets and parentheses. Okay, so for range on this one, we are going from bottom to top. So for range, we are looking at the lowest y value, which is an arrow. And then the highest thing on the graph is also an arrow. So if the lowest thing on the graph is an arrow and the highest thing on a graph is an arrow, that means my range is going to be from negative infinity to positive infinity. So for inequality notation that's going to be written as negative infinity, is less than y is less than positive infinity. And then for interval notation, we just use our negative infinity to positive infinity, put a comma in between them, and then these both get parentheses. Infinities always get parentheses, numbers always get brackets for today. That's not true for your entire life, but it's true for all of Algebra 1. Okay, We got one more, and this one, it seems harder, but it's actually easier. What is the furthest thing to the left on this graph? Furthest thing to the left. What? An arrow. So the furthest thing to the left is an arrow. What's the furthest thing to the right? Another arrow. So if it's arrow to arrow, it's negative infinity to positive infinity. So for my domain, this is going to be negative infinity is less than x is less than positive infinity. To write that in interval notation, we'll use parentheses because infinities always get parentheses, and it'll just be negative infinity, comma, positive infinity. Something to point out, it's really tempting to label this as positive infinity because it's higher. We don't care how high or low it is for domain. We care how far left or right it is. So for the leftness of it, it is negative. So you always go from negative to positive. And then for our range, same thing. The lowest thing on our graph is an arrow. The highest thing on our graph is an arrow. So from low to high, it is negative infinity is less than y, it's less than positive infinity. And in interval notation, it's going to be negative infinity to positive infinity. Okay. We are going to go back and look at what it means to be a function. And then I'm going to give you guys your assignments, but I'm going to give you guys time on Wednesday to work on them because half of our class is gone and it took a long time to get notebooks set up and get attendance done. So we'll finish up on Wednesday. Okay. I'm going to flip back to the front. We're going to talk about what it means to be a function. So is it a function? A function is a relationship in which each x value has only one y value. When we are looking at a graph, we can use the vertical line test to check. If a vertical line crosses the graph more than once, it is not a function. So for example, if my graph looks like this, I'm going to have a vertical line. It would cross right here and right here. This would not be a function. The reason why that is not a function is if I say this x value, I don't know whether I'm talking about this y value or this y value. So I've got to be able to know that each x value only leads to one y value. If my graph looks like this, every time I draw a vertical line, it's only ever going to be crossing once. So this one is a function. So I just wanted to give you a couple examples down here, and then we're going to just go circle yes or no on the back. So on the 3 on the back, this first one, if I draw a vertical line, it's going to cross more than once. So this one is not a function. On this next one, if I draw a vertical line, it's going to cross more than once. So this one is also not a function. Okay, and then this very last one, I would be able to draw a vertical line anywhere. I'm just going to drag my pin across. I would be able to lay a vertical line anywhere, and it would cross, so this one is a function. Okie dokie. To glue these into your notebook, there's that little tab there. You can fold over that little tab and put glue just on the tab. And then you want to glue it in this way, because then it'll be right side up from both directions. And I, of course, don't have a glue stick. I'm going to use a piece of tape. So, if you were to put glue all over this, which I don't have a glue stick with me, so I'm using a piece of tape, and then glue that down, it should sit like this. You can see this, and then flip it up and see the parts on the back, and it doesn't hang out anywhere. Okay, I'm going to stop my recording and bring you guys your assignments.